If you're designing a test setup, there is a method to help ensure success. Watch this video for 4 key steps in making decisions to help ensure you get good data. At DTS, we love to help customers find solutions to measurement challenges. A lot of these questions center on making top-level decisions. This includes everything from choosing appropriate sensors to making the correct DAS setup decisions to get that high-quality data. Hi, I'm Mike Beckage, co-founder of DTS, and this video provides a checklist for success as you put together the system you need to get the measurements you want. My checklist has 4 items. Step 1 is to make sure that you understand any measurement practices, guidelines, or requirements that cover the type of testing you are doing. Whether you're doing automotive, aerospace, industrial, or biomechanic work, there are probably standards and recommended practices that apply to what you're trying to accomplish. Be sure to do your homework. Standards and recommended practices that may apply to your testing activity include SAE J211 and ISO 6487 for general data quality, Federal Aviation Administration or FAA requirements for aerospace, and National Highway Traffic Safety Administration standards for automotive safety. There are plenty of others, but these are some to get you started. Step number 2 is to determine the specific measurements needed. This may include a combination of acceleration, force, strain, angular rate or velocity, temperature, or other parameters, and, very importantly, the expected measurement range. This could be 500 Gs for an accelerometer or 8,000 degrees per second for an angular rate sensor. Step number 2 also includes determining the required data bandwidth or the range of frequencies over which accurate and linear data are required. Bandwidth is normally specified as a range of frequencies, say for example 0 to 2000 Hertz. Step number 3 is to apply what you've learned regarding range and bandwidth requirements and then choose appropriate sensors to meet those needs. It's also important to note that there are some environmental considerations you should keep in mind. Things like stability as the temperature changes and any exposure to shock and vibration. Step number 4 applies primarily to the data acquisition system. The research you did in steps 1 and 2 applies to the entire measurement system, and so the DAS specs and setup parameters must also support these requirements. When I train DTS staff or work with customers, I explain that there is a method to make these decisions. First, I start with the required measurement bandwidth, for example 0 to 2000 Hertz. Then I pick a sampling rate at least 10 times the measurement bandwidth. 20 times the measurement bandwidth is actually better and helps minimize sampling error, and 20 times the bandwidth is actually required by SAE J211. Please note that bandwidth and sampling are 2 different things. Bandwidth is the range of frequencies over which accurate linear data are required, and sampling rate is the sampling rate required to accurately reproduce those waveforms. Next, we need to apply a low-pass anti-alias filter in front of the analog-to-digital converter. The purpose of this filter is to allow the signals in the required bandwidth to come through unattenuated, but also significantly attenuate or reduce the amplitude of signals above the required bandwidth in order to minimize aliasing. When using a DTS system to record a 2000 Hertz bandwidth, we would recommend using a minimum of 20,000 samples per second as a sampling rate. If you do this, our software will automatically select an anti-alias filter frequency cutoff of 4000 Hertz, thus meeting the requirements of allowing the signals we want to pass through, but cutting off signals that could be aliased by undersampling. There's a lot more to some of the topics I've discussed in this video, but hopefully this checklist for success will help you make the critical decisions necessary to ensure you get high quality data. We have lots of additional information on our website and help center, so take a look and let us know if you need help. Happy testing!